Right now, there is a big or small box next to you. One of its sides is mirror smooth, and while you're watching this video, this box is showing you an image. It speaks words in my voice and plays music at the same time. With its help, I'm talking to you. It keeps your secrets and the secrets and thoughts of others. How does it do that? Hello everyone, this is Epoca Netovaria with you. And with this video, I'm launching a new section on my channel under the general title, Bozhiy Promysel. And no matter how this phrase sounds to you, it's not exactly about God, but rather about some unexplained phenomena that are often attributed to divinity. And who knows, maybe in the end we'll find it. If you haven't guessed yet, in this video we're going to talk about electricity and some quantum phenomena. Yes, the very same electricity that's not only in every house, but in every room, car, and in all devices. Yes, in fact, our entire civilization now depends on it. That's exactly why everyone knows about electricity. It runs through pipes and wires into outlets, accumulates in batteries and accumulators, and then is used in various devices. In any store, you can buy a large or small bottle of electricity or even a whole bucket. If you suddenly run out of electricity, you can refill it at the nearest well. Some people install electricity collectors right on the roofs of their houses or cars. No problems at all. Every school child knows that there are 220 volts of alternating current in a power outlet. Everyone knows there's a plus and a minus, some kind of phase, but that's already more complicated. In other words, our entire civilization has been actively using electricity for at least 300 years. And for the last 50 years, life without it is simply unimaginable. It would seem that we should know everything about it. To some degree, that's actually accurate. However, if you dig a little deeper, it suddenly turns out that we not only know nothing about electricity, but we know absolutely nothing at all. The greatest minds of humanity, such as Einstein, Faraday, Maxwell, Tesla, and many others, worked on understanding the nature of electricity, but they never really got any closer to understanding the question. And at this point, it's absolutely necessary to explain why I claim that humanity knows nothing about electricity. Well, of course, those who are in the know understood everything perfectly because it's no secret. And to this day, the Nobel Prize for someone who can explain what electricity is has not yet been awarded and is still waiting for its scientist. Well, for everyone else, let me explain. Modern knowledge about electricity is descriptive, not explanatory in nature. In other words, we have accumulated a lot of experience in observing electricity and its observable effects. And we have understood that there is a connection between electricity and magnetism. We have also been able to derive certain relationships and, based on them, create formulas that allow us to calculate these relationships and effects in advance. We have also created a model that allows us to schematically, using analogies, demonstrate how we imagine this. But look, the query is, what is electricity? The answer is from Wikipedia.
Electricity is a set of phenomena caused by the existence, interaction, and movement of electric charges.
So, for a school student, such an answer is fine. But for an adult, this answer doesn't explain anything. It just postulates that such a property exists, and that's it. Well, it just exists, and that's the whole answer. All right, so what then is an electric charge?
An electric charge is a physical scalar quantity that determines the ability of bodies to be a source of electromagnetic fields and to participate in electromagnetic interactions.
It's a scalar quantity. A quantity of what? Seriously, this is getting funnier and funnier. So what is a scalar quantity then?
A scalar quantity in physics is a quantity each value of which can be expressed by a single number. That is, a scalar.
Quantity is defined
only by its value.
This is the value. That is, in other words, if you strip away all the fluff and call things by their proper names, electricity is a phenomenon determined by the existence of its own value. That is, it's almost directly stated that we don't know. And what does Faraday say about this, for example? Atoms of matter are somehow endowed with electric forces, somehow endowed. A good answer, right? Or what is electrostatics? We see a huge number of formulas, which speaks of a lot of scientific work done, of a tremendous number of experiments, as a result of which all these equations appeared. But there is no answer. Or what is an electric field? And again, we only see a description of the effect, but not a word about why the field is exactly like that, or even what it actually is. And it's not surprising, because even Einstein was never able to create a unified field theory. He only described particular cases. Same applies to electric current. It is given the following definition. It is the directed movement of charge carrier particles, electrons. All right, so what have all our geniuses been doing all this time? Well, they were the ones figuring out dependencies, describing electrical effects, and deriving formulas and equations that allow us to predict the future behavior of energy. In other words, to use it. Undoubtedly, they did a titanic and brilliant job, but at the same time, they didn't get even a millimeter closer to understanding it. Thanks to their work, we are now able to enjoy all the benefits of civilization. But the problem itself persists. We still don't know why electricity arises or what it actually is, just as we didn't know before. But the needs of civilization are growing. For further technological breakthroughs, we simply need understanding. With each passing year, humanity's experience grows, and newly discovered effects no longer fit into standard explanations. To justify them, new theories are invented, which are more like crutches or patches than true understanding. For example, quantum physics appeared. All unexplained effects were decided to be sent there. New formulations emerge, new quantum laws, which no one can understand or explain either. And when we say no one can, it really means no one. Even the physicists themselves admit that they don't understand quantum mechanics. Basically, quantum physics is like a trash bin where all the inexplicable things are dumped. But look, who was at the foundation of this science? First and foremost, Albert Einstein. This was to be expected, because after two almost contradictory theories of relativity, he realized that something wasn't adding up. Something wasn't fitting together. Another founder is Schrödinger with his famous cat, which can be both alive and dead at the same time. And also Max Planck, Niels Bohr, and others. They are undoubtedly geniuses, but that's not what we're discussing now. About the inconsistency of electric current as the movement of electron particles, it seems like everyone has talked about it except the lazy ones. But here's the most common example. Physics tells us that electrons move from one atom to another, but chemistry claims that atomic bonds are unbreakable. And to tear one electron from its orbit, you need just a gigantic amount of energy in thermonuclear processes. And then with a straight face, they tell us about ions and cations, atoms that either lack electrons or have extra ones. Where they come from and how they are held in the atom, no one knows because, by definition, an atom is electrically neutral. The number of positively charged protons is exactly balanced by the same number of negatively charged electrons. That means there simply shouldn't be any charge to hold extra particles. Yes, actually, the very concept of energy isn't really explained. It's only said that it's some kind of scalar quantity. A quantity of what, exactly? By the way, the very concepts of ions and cations were introduced by Faraday. So, even back then, it was clear that the physical model of the process couldn't withstand criticism. However, with the help of patches and
Crutches like
quantum physics and the introduction of additional particles, it was somehow possible to cobble together a more or less working model. But with each year, the required number of them grows. Scientists keep coming up with more and more patches. Bosons, Higgs particles, nucleons, baryons, mesons, hadrons, quarks, leptons, photons, gluons, and our favorite, gravitons. Every new step forward makes our Frankenstein get covered with more and more patches. Remember the famous experiment that baffled scientists, shooting individual electrons at a target with a barrier in front of it that has two slits. In this case, a single electron passes through both slits at once, displaying all the properties of a wave and leaving an interference pattern on the target. The intriguing aspect of this experiment is the so-called observer. Supposedly, when an observer is present, electrons stop behaving like waves and immediately turn into particles. It's like magic. The interference pattern disappears. This moment fascinates listeners so much that they stop asking critical questions and immediately want to believe in a miracle. But I immediately have 3 questions. First, but why? How did you determine that in this experiment the gun shoots individual electrons? Does it have some kind of separate magazine with cartridges in the form of individual electrons? Where did they get them from? Second question, how did they manage to detach an electron from an atom without a nuclear reaction? And why are they so sure that the electron is flying alone and exactly where they shot it? Third question, how exactly is the passage of the electron detected? Well, I mean, how does that very observer actually work? After all, these objects are so tiny and fast that we physically can't see them in any way. At this level, even a single photon of light becomes a massive object, which in order to register the event simply has to collide with the electron and thus change its properties. For example, speed, direction, or, God forbid, of course, mass or charge. All these basic questions are answered immediately, which destroys the mystical aura around the observer experiment. But all questions are disregarded for the greater goal. Well, all right, we'll get back to this later, but for now, let's see what they tell us about temperature and superconductivity. What is temperature? At school, they teach that temperature is the motion of atoms. The faster the particles move, the higher the temperature. That is, an atom itself doesn't have any temperature, it just moves at a certain speed. Let's check the encyclopedia to verify that information.
Temperature is a physical quantity that characterizes a thermodynamic system and quantitatively expresses the intuitive concept of varying degrees of heat of objects.
And once again, we come across a description not of the phenomenon itself, but of its effects. Nevertheless, after a brief search, we understand that temperature is somehow related to the amount of energy that a particle possesses. That is, the greater this energy, the higher its speed and the higher the temperature. The less energy, the lower the temperature and the lower the speed. So, we need to find out what energy is. And here we return once again to the very beginning.
Energy is a scalar physical quantity that serves as a universal measure of various forms of motion and interaction of matter, as well as a measure of the transformation of matter's motion from one form to another.
Energy is a scalar quantity that characterizes the maximum work a body can perform. It is not a particle, not an atom, not a proton, and not an electron. It is a quantity, a measure of something, a closed circle and nothing specific. It's time to introduce a new elementary particle, the energon. And by the way, it hasn't been invented yet. Well, all right. Let's just accept everything as it is again and try to understand the phenomenon of superconductivity. It occurs when a substance reaches extremely low temperatures, close to absolute zero, that is minus 273 degrees Celsius and a little more. As a result, the substance loses all electrical resistance and even its own magnetic field. It becomes almost invisible, completely transparent to electric current. Quantum effects appear in the macro world, for example, levitation. However, here a question arises. If electrons and protons in an atom practically stop their movement due to the lack of energy, then what flows freely through them, allowing electric current to move without resistance? The electron definitely can't, because according to the conditions of the experiment, it has completely lost its energy. Then what? You can't help but think that electrons in an atom, moving at normal speed and at normal temperature, only interfere with the flow of energy, causing resistance. Makes sense. Nevertheless, a rotating superconductor somehow generates an electromagnetic field that allows it to levitate. What is the magnetic field in a rotating superconductor made of if the superconductor itself is absolutely inert? In this simple way, it just leads to the conclusion that there is no physical vacuum, and that all the space in the universe is filled with ether, which in turn is not some kind of substance made up of microparticles, but is the very matter, the very energy, and the very universe itself. But of course, all these effects and the phenomenon itself are immediately attributed to quantum physics. And now imagine all that pile of particles that quantum physicists have come up with. They all have to fly through space at the same time, like a crew on a ship. One is responsible for mass, another for gravity, the third particle is responsible for time, and the fourth and fifth are carriers of energy and charges. But the energons themselves haven't even been discovered yet. And what if this whole crew ends up in a region of the universe where there are no energons? Well, there just aren't any, so what then? Or maybe energy is everywhere, but we just assign it a numerical value so that, God forbid, no one gets the urge to call it ether. One of the main questions we still have to answer is why? Why reject such an obvious and logical theory? Why, for example, did we even need the double-slit experiment in the first place? Who could have come up with that idea? And this is where history can help us. Back in the distant year of 1678, the Dutch scientist Christian Huygens proposed the wave theory of light. However, at the same time, another equally famous figure was gaining popularity, Sir Isaac Newton. This Sir received his first knowledge of optics from Huygens, and after his death, he created his own corpuscular theory, which stated that the whole world consists of indivisible, tiniest particles, corpuscles or atoms. By the way, at that time, Europe was mired in the War of the Augsburg League. The whole world was divided into large pieces. 100 years later, in 1803, Thomas Young appeared, who disagreed with Newton and developed Huygens' wave theory. He was the one who invented and first demonstrated the famous double-slit experiment, specifically to prove the wave nature of the universe. As if by coincidence, just like a century prior, the world is again torn apart by conflicts. The Napoleonic Wars in Europe, the Civil War in America, and war in Australia. And by the way, here's another interesting fact. It was he, among other things, Thomas Young, who came up with and first used the term Indo-European languages. But that's not all. It was he, not Champollion, who is the true decipherer of Egyptian inscriptions. It was he who worked with the Rosetta Stone and then passed his knowledge to the 23-year-old Champollion, who then shamelessly used it and thus claimed authorship for himself. But we got sidetracked. Thus, as a result of his work on the wave theory, Young acknowledged the obvious and tried to popularize the ether as a kind of fundamental basis of the universe. And since this double-slit experiment shattered the corpuscular theory to pieces, Newton's supporters had to use it to try to prove the opposite. Yes, exactly for that reason. Practically every such experiment over the past 200 years had only one goal: not to observe the passage of electrons, as you might think, but to prove the corpuscular theory and disprove the wave structure of the universe. And that's exactly why crutches and patches like photons, muons, quarks, gluons, bosons, and other such entities were invented. This especially applies to quantum physics. At certain moments in history, almost all well-known physicists and chemists participated in this debate, including Mendeleev, who tried to reconcile the sides by proposing a Solomonic solution: ether as a zero element, a zero particle. However, Newton's supporters proved to be irreconcilable, and this version of Mendeleev's table was never published. Thus, we can clearly observe with you some unnatural opposition between the two. Let's call them schools of physics. It creates the impression that they were not concerned with the true nature of things, but with something else. You're not talking about a conspiracy. Indeed, Toy, it seems that the kind of conspiracy theory we're used to doesn't exist here. Judging by the signs, it's much more serious. Do you want to see history's architects? Here they are.
One day, sir, you will tax electricity.
A reply to Sir Gladstone, Chancellor of the Exchequer of Great Britain, to the question about the practical use of electricity. The year 1850. You can deceive one person endlessly. You can deceive everyone once or twice, but it's impossible to deceive everyone forever. People sooner or later realize that they're being led by the nose. Alternative theories appear that explain everything much more simply and clearly. What I started to touch on in this video is obviously not just clear to me. And quite a while ago, I talked about Huygens and Jung, about their struggle with the Newtonian understanding of the world. But even now, alternative scientists are appearing. Our versions are a little different, but overall they're very similar because we live in the same world. One of these researchers was Vadim Lovchikov. On January 27, 2021, on his own birthday, for unknown reasons, he left us. Blessed memory to a man who was able to ask simple questions. Friends, none of us are immune to mistakes. And if you see a flaw in my logic, don't hesitate. Leave a clear, well-written, and fluent angry comment under the video. To be continued, subtitles to be continued.